This is the first example that we are going to discuss. Find the equations of tangent and normal to the curve y equal x square plus 2x plus 3 at P 1, 6. Find point Q where the normal intersects the curve again. So first we have to differentiate the given function to find the general gradient of all tangents. Differentiate this dy over dx, that is 2x plus 2. So this is the gradient of any tangent to the curve, but we have to find the tangent at point P, which is 1, 6. How to find that? dy over dx at P, which is 1, 6. Substitute x equal 1. 2 into 1 plus 2. The answer is 4. So gradient of the tangent at P for this function is 4. Now we have to find its equation because we want equations of tangent and normal. So what is the equation we are going to use? Y minus y1 equal gradient times x minus x1. Then what is our coordinate? 1, 6. What is our gradient? 4. And y minus 6 equal 4 times x minus 1. Simplify this. Y minus 6 is 4x minus 4. Then this is y equal 4x. Send 6 here. That is plus 2. Y equal 4x plus 2 is the equation of the tangent. Now we have to calculate gradient of the normal to find equation of the normal. So what is gradient of the normal? That is minus 1 over gradient of tangent. From this theory, gradient of tangent into gradient of normal, since they are perpendicular, their product is equal to minus 1. So if 4 is the gradient of tangent, send 4 here. Gradient of normal will be minus 1 over 4. And gradient of normal is minus 1, 4. Then use the same equation to find its equation. Y minus, what is the y coordinate? 6. Gradient x minus, what is the x coordinate at P? 1. Okay. Here we can multiply all the terms by 4 because we have a denominator here, 4. 4y minus 24. Here 4 get cancelled, but minus 1 is there. That is minus x plus 1. Then send 24 to that side. After simplification, it becomes plus 25. That is the equation of the normal. Now we have to find this intersecting point, Q. My curve is something like this. This is point P. This is the tangent. Then this is the normal. This is P. Here, normal drawn at P intersect the function again at here, at Q. So we have to find that coordinate. It is clear that Q coordinate is on curve and the normal, both curve and normal. Now we can solve equation of the normal with equation of the curve function. You have to simultaneously solve these two to find Q. You can use any simplification method. I'm going to use here y equal x square plus 2x plus 3. I'm going to substitute this y equal this expression here for this y. Then I will have only x terms, I can solve that equation for x to find x. So that is 4 times y. What is y? Y is equivalent to x square plus 2x plus 3. That is equivalent to minus x plus 25. Take these two terms to left hand side. Now simplify like terms. This is the quadratic equation. Now we have a quadratic equation in terms of x. You can solve this quadratic equation to find x values. Now to solve a quadratic equation, you can use the formula we discussed in O level, minus b. What is that? To find roots, minus b plus or minus b square minus 4ac square root divided by 2 times a. This equation to find roots. B is 9, minus b is minus b square. Once again, b is 9, so b square, 9 square is 81, minus 4 times ac. What is a? A is the coefficient of x square term, which is 4, then 4 into 4 into c. What is c? C is the constant term, minus 13. Then minus 13, minus into this minus become plus, divided by 2 times a, which is 8. Okay, this is not differentiation. This is not differentiation application. This is finding roots of this quadratic equation using this O-level formula. 4 times, let's take 13 times 4. 13 times 4 is 52. 52 times 2 is 208. 208. 208 plus 81 is 289. 289 square root over 8. Okay. Square root of 289 is 17. Calculate that. That is a perfect square. 289. Root is 17. Then here we have 9 plus or minus 17 over 8. That is our x value. Then we can find two x values for plus 17 and minus 17. Let's consider plus 17. Then it is minus 9 plus 17 over 8. So minus 9 plus 17 is plus 8. 8 over 8 is 1. So our first solution is x equal 1. Then for minus 17, minus 9 minus 17 is minus 26. Yeah, minus 26. Then we have minus 26 in numerator, minus 26 over 8. You can simplify that further. Minus 26 over 8 is minus 13 over 4. So here we have two x values. Okay, what are these x values? X equal 1 and x equal minus 13 over 4. We have two x values. Why? Why are we getting two x values? Here you can see the normal intersect the curve at Q again. That means it is already intersected at P. So we have to have two x values because there are two intersection points, P and Q. See, x equal 1 is corresponding to our P point. X equal 1 is P 1, 6. So at P, the normal is intersecting the curve. Okay, no need to consider this because this is corresponding to the P point which is already given. This is our solution. That is the x value for Q point, new point, x equal minus 13 over 4. Now to find the entire coordinate of Q, we know x value, substitute that x value here and you can obtain y. Either you can substitute that x value here as well, equation of the normal. You can use any equation, then simplify subject y, that is the y coordinate of Q. This is the x coordinate. Substitute that x coordinate here, then you will have your y at Q.